Now for part B, it says find the total area of the region bounded by the curve C and the 4 tangents shown shaded in figure 1. So it's just a grey area that they've shaded, and we have to work that out. Now the first obvious thing we should recognize here is that the tangents form a rectangle. So if we break this question down, the first thing we need to work out is this distance, SR, and that distance, QR. SR is very straightforward. So when theta is equal to 0, you can see R is equal to 3. That distance is 3. So therefore the complete distance SR is equal to 2 lots of 3, which is 6. That's fairly straightforward. Now, the distance QR requires a little bit more thinking. So SR is equal to 6, that's fine. Let's take a bit of time to have a think about how to work out QR. And key word is actually tangents to C, parallel to the initial line, and perpendicular to the initial line. So PQ and SR, PQ and SR are parallel to the initial line. That should trigger something in our thinking. PS and QR are perpendicular to the initial line. Well, we actually don't need to worry too much about that because we've already worked out the distance SR just by substituting theta equals 0 to work out that distance and then doubling it. So SR is equal to 6. But PQ and SR are parallel to the initial line. How could we use that fact? Well, if we could work out this coordinate here, points on the curve where the tangent is parallel to the initial line, then we simply need to double that to work out the complete distance QR. Okay, so the complete distance QR to work out the height of our rectangle would simply be 2 lots of this distance here. Okay, now in order to obtain that distance, we need to work out the x and y. Well, in fact, we only need the y coordinates of where the tangent to the curve, the point on the curve where the tangent is parallel to the initial line. There are 2 points, but it will again suffice only to look at that point. By symmetry, it's the same. So that would do the job for us. If we can work out the y coordinate of that point, we have here half the distance we're looking for. Okay, let's focus on how we do that. Now we should know that the x coordinate is given by r cos theta, and the y coordinate is given by r sine theta. And the crucial fact here with respect to this question is that we need to find the angle theta such that the point x and y is parallel to the initial line. And in order to do that, we use the equation dy by d theta is equal to 0. These two are very important points, okay? dy by d theta is equal to 0. Okay, so y is equal to r sine theta, which implies since r is equal to 3 cos 2 theta to the power of a half, y is equal to 3 sine theta cos of 2 theta to the power of a half. So we need to find dy by d theta. Now we can see here, or we should recognize that we have a product of two functions. So imagine that's u, and that's v. Then if we look at the usual rules for for differentiating products, it's u dv by dx plus v du by dx. So I'll just do that. So it's u, 3 sine theta multiplied by the derivative of cos 2 theta to the power of a half. Now here we have a function of a function. We need to use the chain rule. The derivative of cos of 2 theta is minus 2 sine 2 theta. We have to bring the power down. So when you bring down the power a half to the minus 2, it cancels out. So we're left with minus sine 2 theta cos 2 theta to the minus half. Plus v du by dx. Now the derivative of sine theta is simply cos theta. So therefore v du by dx is simply 3 cos theta times cos 2 theta to the power of a half. From here, we know that dy by d theta has to equal to 0. So this has to equal to 0. And now we simply need to solve for theta. Now from here, if I multiply through by cos 2 theta to the power of a half, let's see what we get if we multiply cos 2 theta to the power of half. Just looking at how to deal with this minus a half. So I can get around that by multiplying through by cos of 2 theta to the power of half. I am allowed to do that because I've got an equation equals to 0. So what I do to one side, I can do to the other side. So this term, if I multiply through by, I'll concentrate on that. Cos 2 theta to minus a half times cos 2 theta to the power of a half becomes 1. I'm simply left with minus 3 sine theta sine 2 theta. If I multiply that, if I square that, in other words, multiply it by itself, cos 2 theta to the power of a half times cos 2 theta to the power of a half, I'm just left with cos of 2 theta. So it's 3 cos theta cos 2 theta equals to 0. Now, it's obvious here that I can divide both sides by 3. So I did that and write the positive term in front. I have cos theta times cos of 2 theta minus sine theta times sine of 2 theta, which is equal to 0. Now from here, we have a double angle and a double angle. So we need to use the double angle identity. Now there are 3 forms for the double angle identity for cos of 2 theta. There's cos squared theta minus sine squared theta, 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. So before I think about which one to use, if we look at the right expression, there is only one expansion for the sine of 2 theta, which is 2 sine theta cos theta. If I multiply 2 sine theta cos theta by sine theta, let me just deal with that first. What do I get? I get minus, let's change the color, minus sine theta times 2 sine theta is 2 sine squared theta cos theta. Okay, so I've dealt with the right hand expression. So here the sine squared gives me a clue as to which identity to use for the cos 2 theta. So I'm going to use the cos theta bracket. Instead of cos theta, it's 1 minus 2 sine squared theta. Now here, I can see that I have, before I start multiplying out brackets, we take a moment to look at what's common. I can see that cos theta is actually common to both terms. So if I factor out cos theta, what am I left with? 1 minus 4 sine squared theta is equal to 0. Now, so we have 2 things multiplied to give us 0, which means that either the first thing is equal to 0 or the second. But if cos theta equals to 0, that means that theta is equal to pi by 2. But if we look at our initial constraint, pi by 2 does not satisfy the initial conditions, so we can ignore that term. So rearranging and solving this, we have sine squared theta is equal to a quarter, which means that sine theta is equal to plus or minus a half. Of course, without loss of generality, we simply need to consider the positive case because we're rotating in the first quadrant, and that means that theta is equal to the inverse sine of a half, which is pi by 6. So we're almost there, because to work out the y coordinates of the point on the curve where the tangent is parallel to the initial line, we have the value of theta where that takes place, pi by 6. So now, using this condition, we know that y is equal to r sine theta. So therefore, y at the point where theta is pi by 6, we have r, which is 3 cos of 2 theta to the power of a half. So 2 lots of pi by 6 is pi by 3. Cos of pi by 3 is a half. A half to the power of a half is 1 over root 2. Times that by sine theta. Well, sine of pi by 6 is a half. Which means that y is equal to, if I can rationalize the denominator, can't I? So times in top and bottom by root 2, I have 3 root 2 all over 4. Of course, we don't need the x coordinate. We could, if we wanted to work it out. So, and just as a side note, an alternative question could be to work out the x and y coordinate of where the tangent to the curve is parallel to the initial line. But in this case, we actually don't need that. We only now, well, it's elementary from here because QR is simply twice that distance. So 3 root 2 over 4 times 2 is 3 root 2 over 2. Okay, so now we have the distance QR. SR we already said was 6. 3 root 2 over 2. So the area of the rectangle PQRS is 6 times 3 root 2 over 2. So 6 times 3 root 2 over 2 is the area of PQRS, which is 9 root 2. Okay. But the required area, the shaded region, we have to subtract that from the area that we worked out in part A. We have to subtract this area, which we worked out to be 9. So the final answer is 9 root 2 minus 9. So to write it properly, we can say, therefore, A is equal to 9 root 2 minus 9. And that is our final answer.